Hello all, welcome back. So the agenda of today's lecture is that conversion of the flip flops, right? So we are going to convert the one format of the given flip flop into the another format of the flip flop. So before going to convert the flip flop, so what we will try to do is first we will try to learn the what is the design procedure of the flip flop conversion, right? So first we will see that what is the first step we have to do is first we need to draw the truth table for required flip flop, right? So then excitation table for the given flip flop. First we'll try to understand what is the meaning of this one, then we'll go back to the next step, right? So truth table for the required flip flop, then excitation table for the given flip flop. What do you mean by that, right? Suppose if we see here, right? So what is the given question? We need to convert the SR flip flop to JK flip flop, right? So SR flip flop to JK flip flop, right? If you try to understand what is the meaning of, what is the general meaning of this one, so with the help of SR flip flop we need to convert the JK flip flop. It means that what is our final requirement, guys? The final requirement is that we need to have the JK flip flop from with the help of what? With the help of the SR flip flop. That is the meaning of SR to JK flip flop. What is the final requirement? My final requirement is the JK flip flop with the help of what? SR. So this is nothing but they have given SR flip flop. Somehow we need to convert this SR flip flop into JK flip flop. This is your requirement, right? Now if you see that what is the required flip flop here, JK flip flop is the requirement, right? JK flip flop is the requirement, right? So for the required flip flop we need to draw the truth table. It means that for JK flip flop we need to draw the truth table. So with the help of what? SR flip flop, right? For SR flip flop we need to draw the excitation table, right? So once it is done, next step what we have to do is we need to combine the truth table as well as the excitation table in order to form something called as the conversion table. So after that we need to find out the minterm representation, then K-map. Using K-map we are going to find out the logic expression, then finally we are going to find out the logic circuit diagram. That circuit diagram is nothing but in terms of the conversion of SR flip flop to JK flip flop, right? So try to remember this procedure: truth table for required flip flop, excitation table for given flip flop, then step 3 is that conversion table, then finding the minterms. By using the K-map we are going to find out the logic expression. That logic expression we are going to attach to the given flip flop, so that will be converted in terms of one flip flop to the another flip flop, right? So now if you observe here, right, so what is the flip flop we need to do, right? If you see that, so SR flip flop to JK flip flop, right? Now what is the required flip flop here? JK flip flop is the required flip flop. So what is the meaning of this one is, so if you understand, the simple meaning is that what is the flip flop they have given? SR flip flop. It means that, so if we consider circuit diagram it will look like some complex. So for that what we will do is we will just consider the block diagram, right? So one is the clock, another one is the S, another one is the R, then we have something called as the output QN, one more is the QN bar. It means that this is the given flip flop. Somehow this should be converted in terms of the JK flip flop. So what do you mean by this is, so if you consider here, if you find some S value, some R value, then you can able to convert this flip flop in terms of the JK flip flop. First let me just write this block diagram representation. Later on, after performing these all the steps whichever we discuss, we will see how this can be converted in terms of the JK flip flop. First we will draw the block diagram for the given flip flop, that is nothing but the SR flip flop as per the given question, right? Now what is the required flip flop, guys? The required flip flop is the JK flip flop, right? So now what we have to write? So first step is that truth table for required flip flop. What is the required flip flop? JK flip flop, right? So just write the truth table for JK flip flop, right, as we discussed in the previous classes, right? So let me quickly write the truth table. So what is the assumption value? 0 1 0 1 0 1. What is the answer? No change, reset, set, toggle condition, right? So this is what JK flip flop truth table, nothing but required flip flop. Now what we have to write in the next step? We need to write the excitation table for the given flip flop. What is the given flip flop, guys? With the help of SR flip flop only, right? So excitation table means QN plus 1, SR. In the previous class I have explained how to find out the excitation table from the truth table. Then one more thing I have explained the how to remember the excitation table, right? If you don't watch those video, please try to watch those video so that this will be easy, right? So input, one more is the output. So what is the possibilities? 0 0 0 1 1 0 1 1. What is the answer? 0 1 0 cross cross 0 1 0. This is the excitation table for the given flip flop, nothing but the SR flip flop, right? Now what is the step 3 is that we need to form the conversion table. As per our discussion, we need to draw the conversion table. Conversion table is what? Combination of truth table plus excitation table or application table. So it means just we are adding this truth table with the excitation table, right? So for that, first let me write the as is truth table of the JK flip flop, then I will add the excitation table, right? So J K Q N plus 1, right? Just give me a second, guys. J K Q N plus 1. Just whatever the table here, just I am copying it over here. So 0 0, one more is 0 1, one more is 1 0, and final one is 1 1, right? So what is the value? This value 0 1 0 1 0 1. This is assumption value. What is this one? No change, reset, set, toggle condition. The same thing I am copied here. Now what is the thing we have to copy? We need to copy the excitation table also. That is nothing but the conversion table operation, right? So if you see that, what is the inputs we have? Qn plus 1, then one more is the SR, right? But if you observe here, here also we have Qn plus 1, here also we have Qn plus 1. Instead of writing the 2 times, we can write only in terms of the single time representation. So for that, what I am going to do is, instead of writing the 2 times Qn plus 1, just we are writing the single time representation, nothing but the S as well as the R value, right? Now what we have to do here is exactly we need to find out the what is the S value, R value. Then how to find out the S value, R value? See, with the help of this excitation table, this is important, guys. With the help of the excitation table, we are going to find out the SR value. So for XR value means output, right? What is the input value? Is Qn plus 1, right? It means that for this value, we need to find out the what is the S value, what is the R value. Again, I am repeating how to find. Don't copy directly this value into here. If you copy this one, it will be completely wrong. Then you will be end up with some improper solution, right? So how to find out means, if you want to find out the SR value, first we need to consider the inputs Qn as well as the Qn plus 1, right? So for that, first you just only look at this value, don't look at this JK value, because SR will depends upon the excitation table of the Qn plus 1. Don't try to mess with JK value, right? That is not required for us, right? Now what is the Qn plus 1 value here? 0 0. Go to the excitation table. 0 0 means what is the answer? Just write down 0 cross. Next, what is the value? 1 1, right? 0 0 means what? This 0 0 means what? Qn plus 1 equal to 0 0. Just go to excitation table. What is the SR value? 0 cross. Just you write down here. Next, what is the next value? If you want to find out SR value, just copy the Qn plus 1 value. What is that value? 1 1. So 1 1 means what is that answer? Cross 0, right? So next, what is the value? Qn plus 1? 0 0. 0 0 means what? 0 cross, right? Like that we need to write the each and every value. Next, what is the Qn plus 1 value? I again repeat, don't mess with the JK value, right? So 1 0 means what is the answer? 0 1. Next, 0 1 means what? 1 0. 1 1 means what? Cross 0. Next, 0 1 means what? 1 0. 1 0 means 0 1, right? Then one more point to remember is that, right? So why we are doing this one means here I need to find out somehow S value, R value, so that it can become the JK flip flop, right? So for that reason I am doing all these steps, right? Now if you see that, just try to remember. So what is the note here is that this is the next state value, right? Qn plus 1 is the next state value or final output value, right? So before this one we called as the input, after this one we called as the output values. Before this one we called as the input values, after this one we called as the output value. Or one more point to remember is, if it is something input, it should follow the binary sequence, something but 0, 1, 2, 3, 4, 5, 6, 7. Suppose if you consider jk, is it following the binary sequence? No, right? It is 0, 0, right? It means that it is not following the binary sequence. If you consider 4-bit value, this is 0, 0, 0, okay, it is following binary sequence. For next one, is it 1? No, right? It means that it is also not following the binary sequence. Always input should follow the binary sequence. So that what is the input value we need to consider? jk, qn are the input value. What is the output value? SR are the output value. Qn plus 1, before Qn plus 1 we called as the input, nothing but the before next state we called as the input, after next state we called as the output values, right? So try to remember like this, right? Now how many inputs we have? 3 inputs. How many outputs we have? 2 output. It means that exactly we are going to find out the expression for SR. The moment you apply this SR value in this block diagram, this will become the JK flip-flop, right? For those things we are doing all these steps, right? So how many outputs we have? One is S, another one is the R, right? First you find the minterms, then we can implement by using of the K-map method. So find the minterms for S, right? So these are the input values, right? These are the input values, right? What is the minterms for this one? For S, what is the value? So this one, right? What is the meaning of this one? 4. Next one, what is this? 6, right? Plus, do we have any don't care combinations? The don't care combination is this one, right? What is this value? 1. Next, what is the don't care combination? We have at the 5, right? So here also we have the don't care combination, nothing but the 5, right? The same way I am finding the minterms for the R also. Once it is done, so we need to have the 2 K maps. One is for S, another one is for R, right? Which variable K map? 3 variable. Why 3 variable K map? Because we have the 3 input values. One is for S, another one is for R. Now you plot the minterms of S, minterms of the R. So what is the minterms? 4, 6, right? Then don't care R 1, 5. So what is the answer? Don't care R are not required, right? So what is the input value? J, K, Q, N, right? It means that here J bar, J, here you will be getting K bar, Q, N bar, K bar, Q, N, K, Q, N, K, Q, N bar. So what is the answer? Right? S equal to J into, what is that value? Q, N bar. This is the expression for the S, right? J into Q, N bar, right? So again you find the same for R. So what is the input value? J bar, J. So why you are considering here J, K, Q, N means first variable J, K, Q, N, right? So next K bar, Q, N bar, K bar, Q, N, K, Q, N, K, Q, N bar. So what is the value? 3, 7, right? So it means that 3, 7, then one more is 0, 2. 0, 2. How to find out the answer? Something like this. What is the value? R equal to K into Q, N, right? Now this value, this S value, this R value, we need to apply into this one, so that it will become the JK flip-flop. What is the S value? J into Qn bar, right? So J into Qn bar means which logic gate? AND gate. Here it is performing the multiplication, right? One is J, another one is the Qn bar. Just I am taking the NOT gate operation. This output is nothing but S, right? This is output is nothing but S, right? It means that this will be connected to S. What is the input value? One is called as the Qn bar. So another one is called as the J. Now come to R, right? So R means again NOT gate, right? So R, so what is the input value? Qn into K, right? The same thing I am going to consider one more card. This is R, right? R means which I am connected to the R. So one is K, another one is the Qn. But if you observe here we have already Qn bar, right? So it means that what we can do is this Qn bar we can connect it to here, right? So this Qn we can connect it to here. Now see that earlier it is what? SR flip-flop. Now it is converted in terms of the JK flip-flop, right? So fine. So this is the way to convert the one given flip-flop to the another given flip-flop, right? So you just try to recall this procedure, right? So first we are going to write the basic block diagram of the given flip-flop. Then step 2 is truth table for required flip-flop, excitation table for given flip-flop, then combination of truth table and excitation table, then finding of minterms, then finding of K-map. That logic expression will be applied to this basic circuit diagram so that it will become the converted flip-flop, right? So if you remember this one, either you can convert whatever it may be, SR to JK, JK to SR, D to T, T to D, whatever it may be, then remaining all things will be pretty easy, right?